everyone, and welcome to this session. In this video I am going to write a simple Python program to explore the data regarding the coronavirus situation around the globe. I will extract the data from a GitHub repository which is updated and maintained by Johns Hopkins University Center for Simulation Science and Engineering. So first of all, I need to download or clone the data by using a GitHub command. So I copy the address of the repository, and here I write git clone the address of the repository. Press enter. Because I have downloaded it before, it gives me an error that this directory already exists, but if you run this command, you should download the data correctly. I have the data here. Data here. I'm going to use time series of confirmed cases in world, this is in world, and recovered global cases. Here you can visualize, you can see the rows and columns of data. In the case of confirmed global cases, we have this table consisting of provinces, country, latitude, longitude, and the confirmed deaths and recovered cases from the day of 22nd January and up until, I suppose, 7th April. So then I have to load my data. I will assign a variable name, data frame name A, to all of the confirmed global cases, and I will use this line of code pd.read_CSV, and here I will give the pass to the data that I'm going to use. In my case, I have saved the data in a folder in desktop in COVID19. In your case, it might be different. So you should find out the path of the data that you have already downloaded and put it here. The same goes for global deaths and global recoveries. So I load the data, I run the cells. To be sure that all of the data are loaded correctly to your Python program, I can write a.head to load the first 5 rows of the data, as you see here. The same for this is global. In the next cell, I'm going to extract the headers of the columns. So basically column names. I'm going to assign them to the variable named column names. And in this line, I'm going to extract only the columns with the information of the dates. Basically, these columns. In this part of the code, I'm going to extract the global confirmed cases for all of the countries and global deaths and recovered for all of the countries. So I can write a.loc for all of the rows, for all of the countries, and for the first day, 22nd January, to the last day. I do it for the global deaths and global recovered. Next part of the code, I want to create a list of the total confirmed deaths and recovered cases and create a list of all of the confirmed cases in the world. So I create a loop which runs from the first day to the last day for I in dates, and I sum up all of the cases around the world for each day. So basically this function sums all of the rows of each column and appends it to the empty list that I created before here. I can do the same procedure for death sum, recovery sum, and mortality rate. Mortality rate is death sum divided by confirmed sum. So I run this cell. If, for example, I load my variable of total cases, I can see that up until 7th April, we have 1,426,096 infected people, and for total deaths, we have 81,865 people dead, unfortunately. This line of code, in this part, we are going to visualize the data. So basically this part, these lines are defining a title or the label for the plot, and here in these 3 lines I plot the total cases versus the date. So evolution of total confirmed cases versus days. If I run this cell, I get these plots. So starting from 22nd January, the number of infected people is increasing, and right now we are here. Almost 1,400,000 people are infected to coronavirus. And if I want to get the figures for each country, I can create 3 empty lists for the cases of a country and run a for loop for unique countries in my data. As I said before, because there are some countries like Canada, Australia, and some other countries that the data is given based on provinces. So I'm only interested to sum up all of those states and put them in one data frame. So what I do in this line of code, I create a data frame named unique countries, and I use a function named unique to extract all of the columns of countries' regions with unique names of the countries. And I make a for loop in this data frame to extract the cases in different countries for each of the countries, deaths and recoveries. I run this cell. For example, if I load this variable, you see that it gives me a list of total number of confirmed cases in each country up to 7th April. In this line, in this cell, I want to extract the data, newly infected people for each country. So basically what I'm going to do is that I'm going to subtract each column from the previous column to get the newly infected people. For this purpose, I use the function diff to get the difference of each columns and fill NA to remove all of the nans of the data and replace it with 0. And then I run a for loop for all of the countries, for each countries, and append the data for some of the newly infected people to the list named total new cases. For example, here if I write Spain, I will get the newly infected people each day that there is new infected people. I will get it in this list, and this function will sum up all of the newly infected people, and then I can visualize the data again. So in case of Spain, it starts from 22nd January, and we have this flat bar graph that here almost in 22nd March we have a peak, and hopefully it's starting decreasing the number of newly infected people. And finally, I'm interested to fit a curve to my data. Basically, I'm using two distributions, Gaussian distribution and Lorentzian distribution. Gaussian distribution, the formula is given here. Here, A, B, and C are arbitrary real constants. It's a bell-shaped curve. A represents the height of the curve's peak, B is the position of center of the peak, and C is the parameter for controlling width of the bell. So if I use the curve fit feature of the SciPy, I can fit my real data to the curve that I defined here, Gaussian distribution and Lorentzian distribution. So here I get this curve, these two curves, fitted curves for Gaussian, the green one, and Lorentzian, the red one. So hopefully in the case of Spain we have reached the peak, and the number of confirmed cases start decreasing, and based on this curve fitting is expected that in 10 days the number of total cases will be decreased almost to zero or near zero, hopefully. So this is the end of this code. Probably this code has some bugs or it can be improved a lot. So if you have any comment or if you have any suggestions, you can write in the comments of this YouTube channel. And thank you very much for watching this video.